You know it's June and summer's coming when the hot air balloons come out. And it's time for summer. So it's time for us to make our own hot air balloons. So that's what we're going to do. Welcome to the Balloon Shop. Yeah, this week's project is we're going to make some hot air balloons out of tissue paper. I don't think you'll be able to fly in it, but with a little careful math, they should hopefully fly, and we'll have a great time. We're going to make our hot air balloon out of some tissue paper, so it's light enough to float. We're going to get some hot air in it. And to do this, we're going to have to glue together several panels of tissue paper. Quick note, don't use a lot of glue. Less is more. Thin bead of glue right there, and then you can press it together, get a nice little seam there. After gluing together 3 of these sheets, you'll have these panels. We'll call these the panels. You're going to need 8 of these panels all together. As you give these panels time to dry, you might want to kind of be gluing them as you're doing your calculations. It'll be time to do the math. So just start gluing those as we are doing the math. So you'll get your little packets that you can work on together. You're going to turn in 1 per group. But make sure you read through those instructions. There's a lot to it, a lot of math going on here. And so we're going to have to do a lot of math in a little bit of time. We're talking about taking some functions and revolving them. So we've talked about how to use composite functions and make them into graphs, something like this graph right here. Here's a graph that looks something like the cross-section of a balloon. So that's what you're going to come up with. And as you read, you'll find out how. You'll have to experiment a little bit. Using your TI Nspire, using the graph and the table, you're going to get some data. Okay? So what we're going to do is we're going to find our equation of the cross-section, and that cross-section helps us to get the panels. All right? And the panels of the balloon are these things that go vertical here. And then in the end, they're going to look like this right here. So we're going to cut out these panels. This is not the cross section. That's the thing you'll have to think about. This is not the cross section. This is what wraps up and over the balloon. And so that's what we're going to make. So all this math that we're doing is converting the equation that's for the cross section into a 3-dimensional graph. After you do all these calculations here, and with some help from your graphing calculator or TI Nspire, you will need to glue together a bunch of these graph panels. We're going to use this instead of butcher paper. And we need to make a pattern for the panels. Okay, now since this is wrapping up and around, these correspond to the arc distances. And the distance changes as the curve changes, as the slope of the curve changes. So these distances between these lines are not all the same. Okay, and so those are your A distances, the distance these are apart. And then you're going to go up your half of the width, half of the W. Okay, so this line right here is actually half of 1/8 of the circumference at 50 centimeters from the base. Okay, that's what this line right here represents. Again, it's half of a panel, and each panel is 1/8 of the circumference. And the height of this, when we bend our balloon, this should be 50 centimeters from the base of the balloon. And as we move on up, all the way on up here, this line once again, this width right here is half of a panel, half of 1/8 of the circumference. And when this balloon is done, this line right here corresponds to the panel, which will be 80 centimeters from the base. And that'll become clear as it all comes together. Okay, so you should expect these A distances to be quite different. I got 20, 18. That's for my function. Everyone's function is going to get different numbers. Okay, so we're going to cut that out, And then we're going to use that to cut out these panels.